Hello folks, today we are going to discuss how Stream API is going to help us and how Stream API has transformed the way Java used to be written before Java 8. I mean, before the introduction of Lambda function and Stream APIs as part of Java 8 release. So in the previous class, we have seen how Lambda expression is created, how it is supported by one special kind of interface called functional interface. In the current class, we are going to see how that is used in Streams API. Before we begin with Stream API, let me give you an idea what Stream API actually is. So Stream API is actually going to work on the collection objects. Stream API provides you beautiful things like it supports functional programming style, and Stream API hides the looping part of it. So if you need to loop through an entire collection in Stream API, you don't have to do that. Stream will do the iteration internally and get you one object at a time to operate. Even Stream API supports parallel processing. Now, parallel processing is very different than multi-threading. Parallel processing uses the power of parallel processor. If your machine supports or if your machine has more than one processor or more than one core, so parallel processing is going to utilize that. So this is very powerful. This is built in with Java 8 Stream APIs. It has many operations which are lazy operations in the sense they will not be evaluated until there are some operations called terminal operations. Okay, so all the operations, there are two kind of operations mainly. One set of operations are called intermediate operations, and there is another set of operation uh, we call them terminal operations. Okay, so until it receives a terminal operation, it's not going to perform anything. Considering that feature, we can consider Java Stream as if like it's an assembly line in manufacturing. So where we put the structure of a car and then it goes through a multiple checks. Let's say at any point it found that the car is not well fitted, its measurement has issues, so it is thrown out of the belt. And if car is good, then other things like engine, wheels, and other things are getting integrated. And the structure of the car, which is there at the beginning, it is keep on getting transformed. At the very end, we get a full, complete car, complete usable car. So similarly, one more thing we can relate to with Java streams is how data pipelines work in ETL. So you can consider that the stream is like their data source. Then it has transformation trail steps. So that can be achieved through multiple functions in stream like map, filter, which changes the object. Then we have aggregators like reduce, collect to perform aggregation, different kind of aggregation on the data. And finally, we can take the output in some other form, maybe which is maybe supported by different stream method like toList or forEach. And the execution starts when we receive a terminal operation. I want you to see this a little different way. I want you to see a collection as if it's a database table, whether it's a list, whether it's a set. We can consider this as a database table. We can compare them, we can relate them. Now, if we consider that as a database table, so let's say we have student. Okay, this has only four members. Okay, and it has few methods which are necessary, like it has constructors, no R constructor, R constructor, and it has a toString method and its getters and set. Now, if I have a table correspond to this, that would be students table. having 4 columns in it. So we can consider this as the whole table. I have created a students list with 8 student objects. Each student object represents a record or row in a table, and each field represents a column, whether name, roll number, course, total. Now, how am I going to teach you this? I am going to consider and compare the operations how we perform in SQL and how it is being performed in Streams API. So with that, let us first start with this simple operation. I want to print all the students. So it is going to be in SQL, it's going to be select star from employees. Now I am going to use Stream API for the very first time. Now one important thing to let you know, so how Stream API is going to use Lambda function. See, if you see, almost all the method of Stream API takes one or more Lambda functions. It's not going to take normal arguments, primitive or objects. It's going to take Lambda functions all the time. I have this SQL here. I'm going to write the corresponding thing in Java. So it is Java Stream port, a forEach method. I need to pass a Lambda function here. So you already know how to write a Lambda function. Let's say I have a Lambda function. It is having only one object. So I'm passing student S. I'm not giving any type or bracket. Then I'm doing sysout and I'm putting S. This S will print the entire object because I have written the toString method here. Okay. Now for each method, how do I know that it is going to take a lambda of this format? If you see here, for each method takes a consumer. This is a built-in lambda function. We will see some more built-in lambda functions. So consumer is a lambda function that takes one argument, but it doesn't return anything. It just consumes. Okay. So let us see how it is going to work. Let us try to run this. If you see, all the students objects are printed. This simple line. So what Stream is doing? Stream is taking one object at a time in the same sequence it's there in the list, and it is passing it to for each, and for each then executing this lambda and passing that object to it, because it's passing that object, you see, it's passing that object to it, and this lambda is internally then printing those objects. So this is for each, which is nothing but if you do a select star from employee, it will get you a similar result. Okay, so the next one is going to be little more complex, like we are going to use where clause in the select. So let us go and do that.